Chapter 2: Theory and Practice. Foundations for Effective Technology Integration. First, let us define what is technology integration. Technology integration is the use of technology resources, computers, mobile devices like smartphones, tablets, digital cameras, social media platforms, and also the internet, and etc., in daily classroom practices and in the management of a school. Ingredients for successful technology integration. First, we have is foundation of learning theories. Second, technology pedagogical content knowledge, or the TPAC. Third is technology integration planning model, or the TIP. Fourth is essential conditions for integration. Successful technology integration is achieved when the use of technology is routine and transparent, accessible and readily available for the task at hand, supporting the curricular goals and helping the students to effectively reach their goals. Learning theories as basis for integration models: integrated, directed, and constructivist. Learning theories as basis for integration models. For directed models, these are the following. Learning is transmitted knowledge. Teaching should be teacher-directed and well-structured. Last is instruction is sufficient. For needs and problem address, these are the following. Individual pacing and remediation, making learning paths more efficient, performing time-consuming and labor-intensive tasks, and last, providing self-instructional opportunities. For constructivist models, these are the following. Learning is constructed knowledge. Second, teaching should be well structured, and last, instruction is sufficient. For needs and problem address, these are the following. First is addressing motivation issues through interactive activities, learning how to work together and problem solving, and last, using high-level and low-level skills at the same time. Technology integration strategies based on each models. For directed models, these are the following. Remedy identify weakness or skill deficits. Second, promote fluency or automaticity of prerequisites. Third, provide efficient self-paced instruction. Last is support self-paced review of concepts. For constructivist models, these are the following. Foster creative problem solving and metacognition. Second, allow for multiple intelligences. Third, build mental models and increase knowledge transfer. Last is foster group cooperation. For both directed models and constructivist models, first is generate motivation to learn. Second, optimize scarce personnel and material resources. Third, remove logistical hurdles to learning. And last, develop information literacy and visual literacy skills. Directed technology integration strategies, theoretical base. First, we have behaviorist theory by B.F. Skinner. According to B.F. Skinner, it treats learning as a response to stimulus. The brain's processes are not considered and viewed as a black box. He believed that teachers' job was to modify student behavior. Mastery learning. In teaching and learning, a process of conditioning students to properly react to stimuli to provide incentives, and technology can help facilitate this. Next is information processing theory, or cognitivist theory, by Atkinson and Sheffran. According to them, a learning theory that focuses on brain functions and how information is processed, stored, retrieved, and applied. The mind as a computer and sensory registers. Another one is the cognitive behaviorist theory by Robert Gagne. According to him, the model of instructional design is based on the information processing model of the mental events that occur when adults are presented with various stimuli and focuses on the learning outcomes and how to arrange specific instructional events to achieve those outcomes. Under cognitive behaviors theory is the events of instruction. It can be used in designing lesson plan, gaining attention of the students, informing the learners of objective. Another one is managing the complexity of teaching. It is to ensure effective and systematic learning program as it gives structure to the lesson plans and holistic view to the teaching process. For inquiry-based technology integration strategies, theoretical base. First, we have social activism theory or constructivism by John Dewey. According to John Dewey, learning as a social experience. And he believes that learning must be hands-on, based on experiences, and is most effective when students work collaboratively with other students on similar tasks. Constructivism focuses on children acquiring knowledge by constructing inquiry within their environment. Next is the scaffolding theory by Lev Vygotsky. According to Lev Vygotsky, to help learners achieve independence, Vygotsky outlined scaffolding as a tool for growth. Learners complete small, manageable steps in order to reach the goal. And also learning as a cognitive building process. For Vygotsky, zone of proximal development refers to the range of abilities an individual can perform with the guidance of an expert but cannot yet perform on their own. Another theories for inquiry-based technology integration strategies, theoretical base, is cognitive development theory by Jean Piaget. He suggests that intelligence changes as children grow. It occurs through the interaction of innate capacities and environmental events, and children pass through a series of stages. Stages of development: sensory motor, pre-operational, concrete operational, and formal operational stage. For instruction support for child development by Jerome Bruner. Discovery learning, a method that encourages learners to build on past experiences and knowledge, use their intuition, imagination, and creativity, and search for new information to discover facts, correlations, and new truths. For multiple intelligence theories by Howard Gardner. He proposes that people are not born with all the intelligence they will ever have. There are 8 different types of intelligence. First is the linguistic or the mathematical, spatial, bodily kinesthetic, musical, interpersonal, and naturalistic. Gardner writes that we may all have this intelligence, but our profile of these intelligences may differ individually based on genetics of experiences. The role of intelligence of learning is the effectiveness of learning is conditioned by the degree of intelligence. Learning is impossible without intelligence. That's according to Howard Gardner. This is the Venn diagram of TPACK, or Technological Pedagogical Content Knowledge Model. So now, this is the illustration of TIP, or Technology Integration Planning. In Technology Integration Planning, for Phase 1, is to reflect on Technological Pedagogical Content Knowledge, or TPACK, self-assessed knowledge domains, or self-assessment is what is my knowledge of technology, or TK for short. What is my knowledge of pedagogy, PK. What is my knowledge of content, CK, and where do I see myself in the TPACK model? For phase 2, determine relative advantage. Why should I use a technology based on method? What is the instructional problem I am addressing? Do technology-based methods offer a solution with sufficient relative advantage? For phase 3, determine relative advantage. The question is, why should I use a technology-based method? What is the instructional problem I am addressing? Do technology-based methods offer a solution with sufficient relative advantage? Phase 4. Design integration strategies. The question is, what teaching strategies and activities will work best? What kinds of instructional methods are needed? How can technology best support these methods? And how can I prepare students adequately to use technologies? Our phase 5 is to prepare the instructional environment. Question: are essential conditions in place to support technology integration? What equipment, software, media, and materials will I need to carry out instructional strategies? How should the resources be arranged to support instructional and learning? What planning is required to make sure technology resources work well? For phase 6, evaluate and revise integration strategies. Question: what worked well? What could be improved? How well has this technology integration strategy worked? And what could be improved to make it work better? So we are now here in essential conditions for effective technology integration. So these are the effective technology integration. First, we have engaged communities. Second, a shared vision for technology integration. Third, empowered leaders. Fourth, standards and curriculum support. Fifth, required policies. Sixth, access to hardware, software, and other resources for sustainable integration. 7. Skilled personnel and opportunities for professional development. 8. Technical assistance. Last is appropriate teaching and assessment approaches. So I'm going to show you a quick slide for the corresponding meaning of essential conditions for effective technology integration. And that would be all. Thank you for listening and watching. Bye.